Good morning, ladies and gentlemen. Today we're going to talk about section 2.5, the intersection of sets. The intersection of sets A and B is written like this: A intersect B. And it's the set of elements that are in both A and B. So if I look at A and B and I look for the intersection of those sets, we are looking for the things that, the A and B have in common. So I would write A intersect B, and let's find the things they have in common. If I look at 3, 3 is also in B. 7, 7 is also in B. 9, 9 is also in B. And I don't see any other elements in my intersection. Now, if your two sets have nothing in common, your solution is going to be the null set or the empty set. And we write that this way: the null set, or you can just write an empty set with nothing in it. All right, let's look at union of sets. Your union of sets, A and B, is written A union B, and is the set of all elements in either or. Basically, we want to get everything without repetition. So if I look at A union B, let's start with our smallest value. -2 should be in there. 1 should be in there. 3 is definitely in there. 5, 7, 9, 10, 11, 12, and 13. All right, that is the set of everything in either A or B. You basically want everything without any repetition. All right, let's say C is the set of numbers such that x is less than or equal to 8. And D is the set of numbers x such that x is greater than or equal to 2. First, we're going to describe each of these in a graph. If I graph x is less than or equal to 8, here's 0, here's 8, it's equal to it, so I have some solid dot, and it's everything less than it. X is greater than or equal to 2, here's 0, here's 2, it's equal to it, and everything greater than it. So if I look at the graph showing their union, I want both x less than or equal to 8 and x greater than or equal to 2. Let's see, I would need to combine this graph with this graph. Here's 0, and it looks to me like when I combine these two graphs, their union is going to be everything. And now let's look at the graph of their intersection. Again, here's 0, and let's look at what they have in common. They have in common from 2 to 8. So here I would have 2 and 8, and everything in between. All right, let's look at the rectangle ABCD. A, B, C, D. Here's the picture of my rectangle. And let's say F is the rectangle, and E is the union AC and BD. So let's draw a picture of E. From A to C is right here. From B to D is right here. And their union would be both. If I was looking at the intersection of those two diagonals, please notice that the intersection would just be a dot. So now I want to draw E union F. If I am unioning E and F, that means I want everything. That is my picture for the union. If I want the intersection of these two, what do they have in common? Looks like I have a point in common here, a point in common here, a point in common here and here. So now I would have A, B, C, D. Those points would be my intersection. All right, let's look look at another example. What makes up the set of the intersection between triangle ZWY and triangle AWZ? Well, let's draw those. ZWY is right here, and AWZ is right here. And what do I have in common? Hopefully you'll agree, WZ. Now notice that length is mentioned here and here. That's another way to tell in your shape's name the fact that these two are next to each other. All right, what makes up the set of AYZ? Let me do it in a different color. How about purple? AYZ. This nice purple triangle. And AYX. This nice red triangle. Hopefully you agree with me that AY is what they have in common. That length, or that segment. And notice again that AY are next to each other in my shape names. All right, we're ready for 2.6. So for tomorrow, I would like you to bring me numbers 1 through 5 on 2.5's covering the reading. And I'll see you tomorrow.